This is a demonstration of VxWorks using the Intel i210 network controller to send TSN messages from one device to another. You'll see the difference between TSN flows and non-TSN flows. The setup on my desk is a simplified version of a network. Here I have two VxWorks devices. This might be a controller sending commands to a robot arm. And I have two Cisco TSN switches. Normally, there would be a whole network of switches with 5 or 6 other devices hanging off each switch. My demonstration shows 2 switches. My VxWorks devices are actually 2 Skylake boards with the Intel i210 network controller in it. And my critical data needs to travel from one sender to the receiver passing through both switches. There's a very tight deadline for reaching its destination. And 100% of its messages must reach its destination, or the robot arm might overshoot its coordinates. So let's see how this works. I'm going to boot up VxWorks. And here is the console to my sender, and here's the console to my receiver. On the receiver, I allow it to listen for some messages. On the sender, I start sending the messages, and the receiver shows messages being received every 5 seconds. And as it prints out its messages, you'll see that the messages are being received very consistently. Every 5 seconds, I receive 500 kilobytes of data. These messages are not using TSN. Even without TSN, the messages look like they're reaching their destination on time. So now I'm going to add more to my setup. What if I had more devices on the switches? Maybe someone with their laptop is transferring huge amounts of data from one end of the network to another. So I have my critical messages that are passing through, and then at the same time I have some other messages now flooding the rest of the network. And the line between the two switches becomes a bottleneck. So let's see what happens. I'm now going to flood the network. And I'm going to flood the network for about 20 seconds. On the receiver side, you can see I'm starting to lose my messages. This can be the equivalent of a stop command arriving a second later than it should, or some sensor data that never reached the controller at all. And when the traffic flooding stops after 20 seconds, my message rate goes back up to normal. For critical data, this non-TSN network is not going to work. So now I'm going to switch over to using TSN. So it's the same setup, but I'm going to now transfer the messages using TSN. Let me now start the receiver to receive TSN messages. And let me start the sender and have it send TSN messages. On the VxWorks receiver, I'm receiving 500 kilobytes of data every 5 seconds. It's no different from what it was like in non-TSN, but now I'm going to flood the network with heavy traffic for 20 seconds. So here it is, flooding the network. Watch the VxWorks receiver. I continue to receive 500 kilobytes of data every 5 seconds. None of the packets are dropped, and all of them arrive on time. And that is how VxWorks, along with Intel i210, uses TSN to ensure the delivery of critical data.